Hi, and welcome to our iOS workshop. In this workshop, we're going to be creating a virtual solar system in our room. So we'll be playing with ARKit and learning how to do this using a little bit of experimentation. Hope you enjoy this workshop.
Let's see. So what well, let's get started then. What I've done is I create. I'll show you in a second. I created some functions to create like the bodies, because what happens is you're reusing the same code over and over again. And so what I did in this particular case is I have a very basic setup, like sort of like the framework that you get when you start an ARKit project. You
Okay.
know, it gives you the delegate and it gives you, I think the statistics gets there. And then I added this one, enables default lighting, so that we'll
Oh,
have reflections off the objects.
nice.
And you've seen this before, we have the world tracking configuration. And then last time when we had all those issues with the, with moving or the touch, you know, when you
Right.
touched
Right.
the feature points, I disabled that,
Okay.
since we don't want any interaction with that.
No.
And then I created a basic sphere, a sphere with a
Okay.
radius of 0.35 meters, and I position it. I actually add a diffuse image, or rather a material on the structure, and I went ahead and imported. Let me show you what those look like. Where's the sun star diffuse? It's basically this thing that you can get open source over the internet, all these different um, textures.
Oh, cool.
Yeah, and so NASA has some, and then there was another website, I forget what it was called, but you can find it on DuckDuckGo or Google. You just go, you know, show me an emissive thing for the Earth, and then something for different planets. So there's even one for atmospheres, which is really impressive. Like you can get the planets, and then you can actually do another property on it to give it a specular. Like, so the Earth has all three. The Earth has the surface of the planet, and then it has an emissive. Let me zoom in on that and show you what it looks like here. Why is it not? How do I view that? I guess I can't view it from Xcode. That's
What
interesting.
does emissive mean in this context?
I'm sorry?
What does emissive mean in this context?
Emissive, basically is how it's emitting light, by itself.
Oh,
So it's for the reflection from it lets you create areas where you're going to have a lot of reflection. Like, for example, the oceans will be very emissive, as well as clouds, and like certain land masses like the Sahara Desert won't be as emissive.
okay.
Um, and then the specular, I'm still not sure how that works. Uh, I don't know really. I don't think I'm able to explain yet the difference between specular and emissive.
Okay.
Um, and then sometimes you just get diffuse properties, and in this case, that's what I got for the sun. It was just a diffuse property. So so we add that in the, we create that first node, give it the radius, and then we tell it the first material diffuse contents, and then we tell it it's a UI image, and then we give it the name from the assets catalog. And then we give it a position, and I always position it for convenience 2 meters away from the origin. So I do the sun position as scene vector make, 3D make, and then tell it X, Y, Z, and the Z axis minus -2. That puts it 2 meters in front of us. And then we add it to the, as a child node to that sort of root node that we discovered last time.
Right.
And then once that's added, we should have simply, yeah, let's go ahead and run it and see what that looks like.
What a sun.
And we should have the, me see if I can, I'm going to reconfigure my screen so I can always have it not hidden here. I'm going to move this way, and that way I won't hide it. There we go. Oh, and I probably want to make my Xcode bigger here. All right.
Okay, that looks good.
Yeah, that's better, right? Easier. Although I don't like the color. I like to have my comments in green. Let me see if I can find a green comments. I don't know why I like green comments. Let's see. No, let's try that.
I think whatever you're used to is, hey, we have a sun.
Yeah. So let's try this one here. See how this looks.
It's getting hot in your apartment.
Yeah. It's really hot. So there she is, about 2 meters. I just went forward a meter. You can see it right there. So now we have a sun, and really cool. It's just sitting there, not just looking pretty cool.
Yeah, it does.
Yeah. So let's go ahead and close that. And what we're going to do now is we want to get the sun spinning slowly. And so I'm going to go ahead and add some code to do that. This is where it gets really cool, how you can animate objects very simply here. Let's see how we're going to do this. So what we want to do now is we want to give the sun a rotation action, basically. A function that basically is going to tell it, well, actually, I'm not going to use a function. I'm just going to actually use the code, and then what I'll do is I'll refactor it and make a function that just does it for us for convenience. But normally what you do is you simply say, okay, create a scene action. So scene action is natively in there, and I think we might have played with this last time. We tell it to rotate by X, Y, or Z, and if 0 does nothing, so we're not going to give it any rotation, but we're going to rotate around the Y axis, and we're going to tell it to take 35 seconds to do a full, or 30 seconds to do a full rotation like this. And the last thing, so that's the first thing, is the action. Then we repeat the call to the scene action class, and we tell it just repeat it forever. Just keep spinning the thing. Otherwise, if you didn't, it would just do it once and stop.
Right.
And then last thing is we tell sun, run action, and then we just tell it what action to run. And so autocomplete, where are you? Sun, oh, there we go. Well, okay, it doesn't want to do, I guess it's not feeling it today.
List, right? Sun rotation action at the top of your list.
Yep, there it is. Okay. And that's it. So let's go ahead and run it and see what this is going to look like. There it is. So it's got a slow rotation. I don't know how smooth it is coming on Zoom.
It's a little bit jagged, but not bad.
Not bad, okay. Yeah, we could probably slow it down. I mean, I could see 60 seconds being a full minute for rotation. We'll just do that. What happened here? What's this warning right here? Sun rotation period was never used. Consider replacing. Oh, wait. Oh, so it probably should have stopped, right? Let's try that again. Let's okay. Make it quicker so we don't have to wait a whole minute, and let's see what happens. Because you notice I put in the wrong action. I put the action, not the period. When I said let sun rotation action, the period itself is not being used. So it should spin for 10 seconds and then stop.
Okay.
Let's see. So I should do a full 360 and stop if my code is, yep, okay. Do you see how it just stopped?
Yeah, I do.
Okay, so to fix that, what we're gonna wanna do is tell it, do this instead. And I'm gonna make it take a minute to go around, although we're not gonna wait the whole minute. So now, instead, we're gonna use the period that actually has the action, right?
Oh, okay.
Yeah, because since SCN action repeat forever, sun rotation action, this sun rotation period includes this action that we declared earlier. So
Oh, I see. I see. I see. Yeah,
yeah,
we want to run the action that's going to go on forever.
right, exactly, yeah.
Yeah.
And there she is. So now it's spinning a lot more slowly, and now it will go on forever.
Cool.
Yep. Okay. So what I did is then, since we're repeating, when we create other bodies, other celestial bodies like the Earth, and we're gonna be repeating the code quite a bit because we're always going to be giving it this rotation action, rotate by, and then we're always going to be saying repeat forever on all the bodies that we create. So what I did is I took this whole block here and get rid of it. Oops, command this, and we're just going to create a function that's going to just do the work for us. So in this case, where's my function? I'll just copy paste that so I don't have to bore you to death while I type super slowly here. So let's just create this guy right here. So node rotation, I just call it node because I figured we can reuse this code later on for other things. And so it's node rotation. So the first thing we send in is the time interval. Again, are we doing this over the X, Y, or Z? And then it's returning a scene action that has the rotation period. So just as before, exactly like before, rotation action and then rotation period. So I took the code here and we don't need this anymore. And since we don't have this, we need to call this function below right here now. So node rotation. So what we're going to do is going to say, let's do let, and in this case, we're going to say sun rotation period equals, and then we call our function node rotation right here. Rotation, and then there's what we need to give it, the time interval of what do we say, 60 seconds. And then a CG X on the X, we're going to go 0. And the Y and the Z, I'm going to 0. Actually, we're going to replace this guy right here with, and I deleted it, but it's basically a CG float to radians. We're going to pass that in as the Y. So we're going to make the X 0, and we're going to change the Y and do that just to keep it the same as before. I mean, it doesn't really matter, but I think visually it might look better to do it that way. So now we just have this little function, this little function we can call, and let's make sure it's working, and hit play, and we should be able to get the same behavior as before. Okay, yep, there it is. And it's a little choppy at first, but now it's smoothing out. All right. So that was there, and now so we have the sun. Now here's something that I learned and I'll show you how to avoid this issue. Any nodes that we add now, remember, like, we can add nodes in a relative or in an absolute manner. So if we add a planet like this, like the Earth, it's going to it's going to be relative to the sun if we add it as a child to the sun, right? So what will happen is the orbit of the Earth is going to be following the sun's spin. And we'll do that the first time. But then the way to avoid that issue, because as you know, a planet is going to probably be orbiting at a different rate than what that, like for example, the moon takes a month to go around the sun. The Earth 28 days, but the Earth is spinning once every 24 hours. So to solve that problem, we create basically a virtual node. We create a node that manages the orbit of the planet, and then a child node from that has its own rotation, so that you have essentially a node attached to a node, and you're not seeing, you're not visually seeing the orbit, if that makes sense. So we're creating like two nodes. We're going to create one node for the Earth that's going to have its own it's going to have its own speed or rotation speed. To illustrate the problem, I'll just do it, as is, without doing the added node in there. Let's see how we would do that. So, like if I do this right here, right?
Are we making a node that has its center at the center of the Earth node, but is basically invisible, and along its edge it has the moon? Is that?
Yeah, exactly. So yeah. So when we create like the Earth to give the moon's orbit,
Yeah.
we're going to create that, right? The parent node is going to dictate the rotation of the Earth, and then there's going to be a child node to that controls the moon's orbit.
Okay.
So that way we can apply, basically what that lets us do is lets us apply different rotation speeds to different nodes.
Right.
And we're going to reuse that, that node rotation function below.
Okay.
Totally well said. So, okay, so we create the Earth node, and we're going to do something with it for the moon as well. We're going to do the moon parent node.
Okay.
Because that lets us have, I'm going to do, moon parent node there. And then we're going to do the position. So this is where we position the parent nodes themselves. So first we created one for the Earth, and now we're going to create one for the moon. And then we're going to do the same thing for the moon position. And I think this could probably also be done, made into a function. So the Earth is going to be positioned a meter. Remember, the sun itself gets positioned in front of us on the Z. So I think what this will do is we'll position the Earth behind the sun. So maybe we don't do that initially. Maybe we'll position it -2 meters on the y-axis. Actually, I want that on the x-axis, not the y. So let's do -2 here. And this will be 0. That way the Earth will be to the left of the sun when we start out. All right, then let's go ahead and add the child node. Let's see, so we have, our sun's already done. We're gonna add we already created the parent node for the Earth.
So let me ask you a kind of a basic question here.
Yeah.
Is the fact that we are creating this hierarchy of parent and children, is that what's going to give us the fact that when the sun moves, the Earth moves with it?
Yes, exactly. So what I'll probably end up doing to make it more realistic, because right now what's going to happen, as you're guessing, is the Earth is going to move around the sun at the same speed that the sun's rotating, right? Because they're tied to one another.
Right.
And what I'm doing is I'm anticipating this issue. So only for the Earth and the moon, because I created a parent node for the Earth and the moon. What I need to do, we'll have to go back and I'll have to create a parent node for the sun here. Instead of creating the sun directly, I'll have to create a parent node. That way the sun, that way I'll be able to split the speed, the rotation of the sun and the rotation of the earth. There'll be two distinct speeds. Because right now, I don't have a way to split those right now.
Sure.
Yeah, so exactly. So the nodes will get created first, and once we have the nodes, I can create the planet itself, and the bodies themselves, and then I just simply add the body itself as a child to the master node. So like here, I'm just going to do it this way. I create the Earth. And I don't have this function yet. I created a function because I got tired of copying it over and over. But basically, you remember like last time when we created a body or a box or anything, we were giving it the diffuse, the emissive, the position, and all that stuff. So what I did is I made one for rotation, and then I'm going to create a function here for
the position. Sure.
Yeah. So basically, we're gonna specify when we create a body what's the geometry, and then all the UI images associated with diffuse, specular, emissive, normal, and then the position. So that all just gets created here. Geometry is probably always a sphere, so I probably can tell it. I don't need to specify geometry here in this case, but.
Well, if you wanted to put a spaceship up there.
Yeah, I mean, I guess it makes sense because sometimes bodies are not exactly spheres. We may have some asteroids that have a weird oblong shape, so I guess that would work. So we're doing all of this just like before: diffuse, specular, emissive, normal, and we're giving it the position, and then we return the body, return the astral body. So here's how we consume that. We're going to say, okay, here's a sphere. The Earth is a sphere of 0.2 radius. Diffuse, what's it complaining about? Earth was never used. Oh, okay, that's fine. We're going to use it. Don't worry. And we have a position of 1.2 on the x-axis. So you know what? I wonder if. So we added the node. Maybe it makes sense to keep it further away from us. Let me do this. Because we are now going to position it relative to the parent. Let's see if this is going to work. So Earth parent node, Moon node. Now we defined the Earth itself. And now the next thing to do is we're going to add it to the parent. So something like this. Let's see here. Earth parent node. We're going to add the planets. So we're going to go here. So we have our Earth parent node. We add the Earth that we just defined. And let's run it and see where we're at. Sometimes I remember not to get carried away before we actually do things and test it. Okay, all right, so there's the sun. I don't see the Earth. Where's the Earth?
We've lost the Earth?
I know. Oh, wait, what's behind? Oh, there's something behind the sun. Looks like. Wait a minute. There's a weird shadow behind the sun. Not sure. Okay, I don't see this. I don't see the Earth at all. What did we forget to do? Well, okay, so I can see something I forgot to do is I didn't add this node to the sun. Remember so we added the Earth node. This guy's not being used yet.
Okay.
Yep, and nor is this guy. That's okay. I'll let them be because we're about to use those. So now what we want to do is we want to add that to the sun itself, right?
Sure, yeah.
Yeah, that's what we didn't do. So rather than add it to the sun, if I add it to the root node, it's not gonna be tied to the sun's motion. Let me see if this is gonna work. So if I add, because we added the root node, the sun, to the root node. If I do the same thing here, if I add a root node, add child node, the Earth's parent node, that's going to give me, at this point, it should give me the sun spinning, but the Earth shouldn't be just sitting there, not doing anything. Let's try that. All right, so our sun, and do we have an Earth? Oh, there's the Earth.
There's an Earth.
Okay, so perfect. Yeah, so this is what we want. We want the sun to be spinning,
Mm-hmm.
and then the Earth is independently just sitting there, not doing anything yet. So this is perfect, right?
Yeah.
Yeah. Okay. Good.
Nice Earth.
It's what?
Nice Earth. It actually looks like the Earth.
Isn't that amazing?
Yeah.
Yeah, it's really impressive. All the detail in it. It's pretty cool. Okay, cool. So now all we have to do is add a rotation. We're gonna use the node rotation on the parent node, I believe, of the Earth. That would make sense, right? So we just added the Earth parent node. So now I want to say we're gonna do two things for the Earth. We're gonna give it a rotation around itself. Let's do that first. So I'm gonna do this. I'm gonna do Earth rotation period. And then I'm going to add that. So I'm going to say Earth rotation period and 15 seconds. That's kind of quick, but let's see how it looks. And we're just going to add that as an action. So we're going to go Earth, not on the Earth parent, but the Earth itself, because the Earth parent, remember, is the orbit around the sun. So I'm going to run action, right? And I'm going to say Earth rotation period.
So now this is going to be the rotation of the Earth about its own axis. Is that correct?
Yes, exactly. Like over a 24-hour period or something. So I could just say, time is 24 or something like that. Even though it's not really meaningful at this point because it's seconds, not hours, but just to kind of
that's fine.
Make it easy. Yeah, it makes it easier to track it. So let's take a look at that and see how that looks. So all right, we got a sun that's slowly turning.
Yeah.
And we have an Earth.
Nice.
That's also spinning nicely at a slightly different speed. You notice the Earth spinning a little faster.
Yeah.
Than the sun. And I think it would make sense actually to have the Earth spin much quicker, considering.
Sure.
Yeah, let's make it a 12-hour day here.
Why not?
Why not? Yeah. So, and now, okay, so cool. So we got the Earth going, and now the next thing to do is let's make the parent spin about the sun. Yeah. So to do that, we're going to just say we're going to declare, just like we did the Earth rotation period. We're going to create something for the Earth parent node. And we're going to make it go quicker. So I'm sorry, slower, because the Earth spins, it takes a whole year to go around the sun. So let's make this 50 seconds or 60 seconds, something like that. So same thing, we just do that. We're using our node rotation function, and we're just going to add this now, not to the Earth. We're going to add it to the Earth parent node. So we do Earth parent node. Earth parent node. Actually, we're going to do is say we're going to make it let Earth parent node create that. Oh, no, wait. No, we already have the Earth parent node. So we're just going to say Earth parent node dot run action like before.
Okay.
And we just give it this. That, if you remember, it includes both the, it already includes the action and then the forever directive. So we have that in there as well. So let's see how this works right now.
Cool.
Yeah. All right, and everything seems to be loading, and oh, there it is.
Wow. Oh, that's so cool.
We'll have even eclipse going on right now. We can't see the Earth. And here she comes.
Here it comes. Oh, that is so awesome.
Is that amazing?
I'm loving it. That, and you just get that whole relationship because you've built up the hierarchy, and the Earth parent is actually an invisible node.
Exactly, yeah.
And wow, and it's huge. Oh, we've eclipsed the sun.
I know. We just got
Wow.
our own eclipse.
Yep. Yep. That's awesome.
Awesome, isn't it? Oh, look at this.
Oh, wow.
Sweet. And so the realism is really impressive. That it, the perspective, everything changes, and and what's cool is what we'll do. I guess in the next workshop would be, since we know we can touch these objects, it'd be cool to be able to interact with them, right? Like just touch it and have it, somehow affect its speed and things like that. It's going to be, and we already created the moon parent node.
Okay, cool.
What we're going to do is we're going to add that to the center of the Earth, and then we'll be able to do the same thing with the moon. The moon now will be a child of the Earth. It'll have its own rotation speed, and it'll have its own orbit speed as well around the Earth. So we'll have basically the sun as the center of the Earth, and then the subchild will be the moon. So we'll do that and have that be able to control the rotation speed of the moon as well. Okay, so let's declare the moon. Okay. Oh, yeah, we need to give the moon some properties. Let's go do that.
Astral body for creating the moon.
Yep, exactly. Yeah. So I'm going to say let moon like that. It's going to be smaller, 0.07 radius. We have the moon Luna diffuse image that we're going to apply. Then we don't have emissive and all these others, so the moon is not going to be as spectacular as the Earth, with the reflection and all of that.
The moon doesn't have a bunch of different material types to have different kinds of reflections. Like there's no land and water on the moon; it's just all land.
Exactly. Yeah. Exactly. So that makes sense. That we don't have different reflection properties to worry about. So that makes it easier.
Okay.
And then once we have that done, we just add the moon as a. We add the moon. Let's see. Do we have the moon parent node defined yet?
Moon parent node is right underneath Earth parent node.
Yeah. So there's. Okay. Yeah. You're right. So we do. We add that. We add that now. So we can just say that. We add the child node itself to the parent. And the next thing now to do is to tell it how, the spin and all that stuff. So let's go ahead and create the spin for the moon. We have the Earth rotation period, Earth rotation, and then Earth parent rotation. I guess I could call it orbit or whatever. That might make it less confusing, but Let's go ahead and do the moon.
Okay.
Moon parent rotation, and oh, I need to do a rotation for the moon itself. All right, let's do that. I'm just going to copy this code right here. And I'm going to call it, all right, moon rotation. And we'll make it, how about we make it go really quick?
Okay, cool.
Make it spin like crazy. Although, yeah, in our case, you don't really see the moon because it's always showing its same face towards us. So, well, I guess that's still a rotation. In this, yeah.
That is a rotation. It's a rotation that matches the rotation of the Earth.
Oh, yeah, that's right. Yeah, it matches yeah, rotation around the Earth and its orbit. Yeah, so maybe I can do that. All right, so let's make a match, 4 seconds.
Okay.
Rotation period and movement parent rotation. And I'll say this, I'll make it, this is the orbit, and this is its, I don't know, spin. Okay. And so now all I have, let's go and let's see, we want to do, okay. Run action, moon rotation period. Let's see what it looks like.
Yeah, yeah, absolutely. This is so cool.
Yeah, this is so much fun. Moon rotation. Oh, I'm not using moon rotation period yet. So at this point, we should just have the moon spinning because we added the moon.
Oh, because we didn't actually tell it to go around the Earth yet.
Exactly, yeah. And I don't see the moon. I think I know why.
In the middle of the Earth, didn't it?
Oh, probably. That's probably what I did. Let me see. Moon. It's 0.5 position.
5. Yeah, that.
Yeah, so.
Sure.
Well, that's really amazing how beautiful the details are on it.
Yeah.
That's really cool. There's like, this is an infinite possibilities. We can even add the International Space Station orbiting around the Earth, right?
Right.
I added the Earth to the Earth parent node. I added the moon to the moon parent node, but I didn't add the moon parent node to the Earth, right?
Okay, yeah, yeah.
So if I add that Earth child node, yeah, we want that. Otherwise, we're not going to see the moon. Aside from potential position issues.
Okay.
But in this case, I think that was
Yeah,
the thing.
that makes sense. That makes sense.
Yeah. All right. Oh, I just saw something that could be a moon. Oh, yes.
And it's going around the Earth.
Yeah.
Oh, that's awesome.
It's got a cool orbit. And now we're.
Oh, that is so awesome.
Oh, that's great. I love that. Oops, there it is. Oh, it looks really cool too. It's very realistic. It's probably a little too fast for Zoom, I imagine, because it's really smooth on iOS.
It's a little bit, yeah, it's a little bit here, but I believe that it looks pretty nice on iOS.
Yeah, it's very impressive on iOS.
Oh, I love that.
Yeah, that was very cool. Okay.
Just for us, right?
Yeah, exactly. So we can definitely slow it down and make it look more. Although if to do this, obviously scale would be an issue because
right. I mean, the Earth is a bit larger than it would be relative to the sun.
Right.
On the other hand.
Yeah, and I think it'd be kind of a neat thing because since we can show since this is AR, we can also use the same tool. Here, I'm going to stop sharing for a moment. So do that. There we go. We can use the same tool to show the relative distance. For example, like if we know that based on our scale that we pick, you know, we say the sun's going to be this big and then the earth's going to be this big.
Yeah.
We could say, okay, this is my living room, and then, you know, Denver would be the actual, or Santa Fe, right, would be the position of the earth. So you could actually zoom to Santa Fe, show downtown Santa Fe, and then see the earth now, and then go back. And so this could give us a really cool way to show the distance and perspective. And then you go back to the, you know, the full model. Yeah, let me go ahead. I'll share it again so that we can get back to, there we are. I lost the, oh, there we are. Okay, screen share. Just trying to kind of play with how quickly we can jump back and forth here.
Okay.
All right. Yeah, I'm gonna make it a little slower so maybe we can see more details. Let's do 20 seconds and 20 seconds here. So let's see. That way it'll give us an idea if they're matching.
Right, right.
Moon parent run action. I didn't run the action. I'm missing something here. Yeah, I'm missing moon. Moon parent node. So moon itself dot run action, and then I'm going to give it moon rotation period. Moon rotation period. That will let it hopefully show always the same face towards the earth. Let's see if that works.
Now I have a really weird question for you. So we've got this set up and it's hanging out in your living room. And if you get up and walk towards this model, does it stay where you put it in the room? So
yeah, so let me do that. I'm tethered to my laptop, so I'm limited to about a meter.
Okay, gotcha.
But you'll see it. Yeah, I can move it. I can move my.
What I'm wondering is if we can physically walk over to the earth.
Oh yeah. Let's check that out. That's a great question. It's actually makes sense. So right now the sun's just about right over my laptop. We don't yet have objects occluding one another. So what happens is iOS, the scene kit, doesn't really know about my laptop yet. So if you'll notice,
sure, yeah.
Yeah, like, okay, so I'm gonna move towards the earth to answer your question.
Yeah.
And check out what happens.
Because I mean, it's kind of interesting to see from the Earth's point of view if this has the same kind of feeling as it does when you're on Earth, you know, with the sunrise,
right,
and all of that.
So I can actually go, this is the cool thing, I can actually go physically move into the sun. Let me see if I can get into the sun. I tried this before, and what happens is I'm not quite reaching the sun. I'll wait till the earth comes around. Where's the earth? I lost the earth. Oh, there it is behind the sun now. Looks like the moon is always facing, I think we did it. Oh no, it's spinning at a slightly different rate. Something's different.
Okay.
Yeah, but notice here, I'm gonna let the earth come into, I'm gonna go into this earth now. I'm actually inside the earth.
Oh, okay, so now we're inside the earth?
Yeah, you can go inside the earth and it doesn't block your view. I lost the earth, but you can actually go into it and then you can still see other objects. Like if I stay here, the moon should come in and hit me at some point. Oh, that's too far. here's what I'll do. Let's make it where the sun is closer initially. I'll make it like 0.5 meters in front of us initially. That'll kind of put the universe right in the middle of my workstation here.
Yeah, that makes sense.
the solar system, rather. Okay. Ooh, it's right in front of me, half a meter in front.
Okay.
And so now this lets me go into the sun. And then you notice when I'm in it,
Yeah.
I don't see anymore, but I can see the Earth's going to orbit around us.
Really cool.
Yeah. Is that really cool?
It is.
And I can just sit here and I can keep turning my iPhone to constantly face the Earth, and we should see the Earth just spinning around us.
Yeah.
And I think I haven't. Let me see what I did here. Yeah, so it's just spinning around us. Although I didn't go behind, I'm thinking. Let's see how this is working out. These numbers here have to match the -0.5 because the Earth parent node is added to the root node. So I have to change this to match it.
So why did you add it to the root node instead of to the sun node?
Because I wanted to have it control the orbit, have it not be tied to the sun's rotation.
Yeah, okay, because we didn't create a sun parent.
Yes, exactly. So we'll need to create a sun parent to avoid this issue, right?
Yeah,
to
gotcha.
avoid that as well. Yeah.
Gotcha.
Otherwise, I have to match these numbers up.
Right.
No, so we would create, instead of let sun, I would create a we can do that. We can do that now. I can just copy this code here. Sun geometry, position, and view right here. We can take all this code out and then just create a separate object. And then that way, when we run it here, let's redo this again. We'll have them on the same orbit, because that's what happens. I had one orbit for the Earth, and then a different position, a starting position for the Earth. Yeah. Let's see if that fixes that. So like right now, let's go up so we can see the whole solar system. Let's see if that's going to work. No, it's still, yeah, there we go. There we go.
Yeah, I think so. I think that's working. Yeah, that's making sense.
Yep, now it's working, yeah. I'm turning around, now you can see me again. Oh, there's the Earth. I feel like Atlas. And where's the sun? Where's the sun? Where are you? Oh, there it is. Yeah, so it's now the orbit is back to proper again. So that's what we'll need to do, is we'll just need to create to make a proper solar system. Is we'll have to create a
just create the entire solar system as a node with parents and children.
Yeah. Yep. Exactly. Yeah. Exactly.
Yeah. The other thing that would be interesting to see in this is to add a comet into it.
Ooh. Oh, right, with an elliptical orbit instead of
it's elliptical, and it's also not in the same plane.
Yeah. Okay, so let's do that. Whew, let's have some fun. Let's add let's do that with I have textures here. Let me see what we have. We're gonna take one of the planets and we're gonna give it let's do Venus. Well, I have Venus already. So what I'm gonna do is we're gonna go in in here, we're gonna add Venus as a different yeah, in a different plane. Let's do that just for fun. We'll pretend it's a
We'll pretend it's a comet.
yeah, exactly. So let's see here. First thing we're going to do is we're going to declare Venus. We'll make a parent node for Venus, like we did for the other ones. And we're going to give it a position just like we did. We'll give it a starting position like the Earth. Venus parent node, and we'll make it 0.5. And then we will add the child node to the root because it's going to orbit the sun. So do the same thing as before. And let's go give it some properties. So, and then the challenge will be figuring out the orbit. Yeah, so let's see here. So we're adding the, we need to add Venus to the parent node of Venus. So let's do that here. And now we're going to do the spin and the orbit for Venus. So let's go down here and let's see. Venus parent rotation. So let's call it like we did the other one. We're just going to call it, and I'm going to call it weird orbit. All right, so this one, we're going to go on we're not just going to do the y-axis, we're going to do x, y, and z axis, right, to make it all funky.
Yeah.
And so let's see here. So this was 360 to radians on, maybe we'll do 180 degrees. See what happens here. And then on the x-axis, yeah, let's play with that as well. And why not the Z as well? Let's try that.
Sure.
Let's see what happens. I have no idea how this is going to work out.
This will be interesting.
Yeah. And then we just simply add it. We'll do Venus parent node, right?
Yeah.
Dot run action. Yeah, run action and Venus rotation period. Okay. Okay, yeah, looks like Xcode is happy so far.
Okay.
And let's run it.
Let's see what it does. So I think eventually to get what we want with the comet, we would have to have the parent node would have to be a different shape, right? It would have to be an oval shape.
Yeah, exactly. To get the actual, oh yeah, look at that. Oh, cool.
Oh, there it goes.
Oh, it's a really funky orbit.
I'm not sure what that's doing.
Oh my god! I think we really went all out. It's orbiting around a black hole that we can't see.
That could be.
This is crazy. It's got all kinds of stuff going on.
Oh man, it's like doing loop-de-loops.
Yeah, it is. This is so cool. Where's the Earth and the? Where did I do with the Earth and the? Oh, there. So the Earth and the Moon are behaving as expected.
Yes.
But Venus is just.
Venus is wacky.
Wacky. Woohoo! This is great.
Well, comets do some pretty strange things, but
yeah, this is the coolest thing though, because we
Oh,
really didn't really think it through. We just said, let's see what happens. And
yeah.
I'm gonna run it again and see what happens. Yeah. Ooh, build failed. Oh, I copy pasta problem here.
Ah.
All right. Okay, where is, oh, okay, let's see.
Oh, well, it's now doing something entertaining.
Yeah. Wow.
Cool. Well, I don't entirely understand it, but it's pretty cool.
Yeah, exactly. Neither do I. Oh man, this is so crazy. But this would be really fun for creating a game because I mean, with a simple change here, it's an unpredictable motion. If you were trying to, to create just some funky far out game. I mean, look at that. It's down here, and now it's like, yeah, it seems to be tied. I think I have a slight idea what's going on. There's an axis from the Earth that it's going around an axis that's a point that's spinning.
Uh-huh.
Like when we set the position, it's using that as a reference point. It's like because it's keeping the same distance, but from the Earth.
Well, you have this on the z-axis now,
Yeah, so that's what's
so it's yeah, yeah.
Wee. Yeah, this is pretty crazy. But I think now is a good place to stop so that we can do some research on
Yeah,
how these node rotations work.
right, right. But this was really exciting. It was really interesting to see things and how to create like the whole hierarchy to make this attached to that and rotate around it and then have another thing rotating around the thing that's rotating around the thing.
Right. Yeah.